Here on part 7 on page 8, you should see in the warm-up, we're going to be talking about subatomic particles you've talked about in other science classes. You need to be able to define these basic terms because we're going to use them all year, and that's what your target is. So defining chemistry, subatomic particles, elements, isotopes, compounds, and mixtures, and then importantly, determining if something is an element, compound, or a mixture, which is what we're going to practice. So the first thing that's listed here is what is chemistry. So we talk about chemistry in general and what this class is, okay? We're talking about study of matter and the changes it undergoes, okay? So we're going to be listing here something about that, okay? So study of matter and changes. So when something changes from one to another, and so okay? So study of matter and the changes it undergoes. The subatomic particles, you don't need to write anything because I've listed them here for you. So this should bring them back to you, okay? So sub meaning the smaller parts that make up an atom, okay? So subatomic, so parts of the atom. We've got protons, neutrons, and electrons. You should have heard of these before. Protons, neutrons are in the nucleus. Protons have a positive one charge, okay? Neutrons don't have any charge, they're neutral. The electrons are in the rings or the shells around the nucleus. They have a negative one charge, they're negative. And the last column here just shows you how much they compare to each other, their mass. So AMU is atomic mass units, which is just this really, really small unit of measurement for mass. But what I want you to see is protons and neutrons have a mass of 1. Electrons don't have a mass of any AMUs. It's actually like decimal point something. So I just want to show you that electrons are a lot lighter than protons and neutrons, okay? Now, what are the elements? So we talked about elements, okay? We've got the periodic table of elements we're going to be studying this year. Okay, so individual items on the periodic table. Items on the periodic table. An isotope, you should have heard of this definitely in other science classes. Okay, if we talk about isotopes of each other, they're going to be the same element, but they have a different number of neutrons. Okay, so same element, but different number of neutrons. That's what makes something an isotope. It's the neutrons that are different, okay? So what is a compound? We're going to be talking about what makes something an element versus a compound, okay? So compounds are when more than one element comes together, okay? Could be 2, it could be more than 2, right? So more than one element together. Now, they're going to be bound together, okay? So it's not like you can just separate them easily. But mixtures are going to be when something's in the same space, but you can separate it. So a good example I always give people of mixtures would be cereal and milk. Okay? Let's say you have Cheerios and some milk. That's a mixture right now because they're kind of together, they're mixing together, but you can easily pull the Cheerios out of the milk. You cannot easily separate the parts of a compound because they have bonds holding them together, okay? So for mixtures, you can write something like in the same area, but not bound together, okay? So 2 plus things, meaning 2 or more, in same area, but no bonds. Okay? Compounds have bonds, that's what makes it different. Okay? Now, this graphic I have down here, okay, kind of helps explain this to you. So matter, you can either separate it easily by hand or not. If you can separate easily by hand, that's what mixtures are. Okay? Now, if they're the same throughout, it's called homogeneous, meaning the same. Okay? So a solution would be an example. So like, let's say you made a solution of like powdered lemonade and water, okay? That's a mixture because it's mixed together, the lemonade powder and water. And it would be even called a solution because it's generally pretty even throughout. It's not like your first 5 glasses are just water and then you get all the mixture at the bottom. Generally, it dissolves pretty well. But you could still like boil the cup of lemonade and still get the water and the lemon to separate, the lemonade powder. If it's not uniform throughout, that's called heterogeneous. Think about a chocolate chip cookie, for example. You've got the batter and the chocolate chips in the same area, but you could pull out the chocolate chips if you want to, okay? Because they're only in certain locations. Soil is another one. It's made up of a lot of stuff. Let's say you have matter that you can't separate easily by hand. So this says cannot be separated by physical means. It means it's a pure substance. If it contains only one kind of atom, it's called an element. If it contains two or more together that are bound, that's the compound. So examples of elements would be anything on the periodic table. Oxygen is on the periodic table, carbon's on the periodic table. Compounds, when they're bound together, water, okay, is made up of two hydrogens and an oxygen. Salt, there are many different salts. We talk about table salt, that's NaCl, so sodium and chlorine together, okay? So let's go here to the test. Classify the elements as compounds or mixtures. First one I see is H2O2. Right away, I'm noticing that you can write a formula for it, okay? Meaning that you're writing out symbols from the periodic table. H is hydrogen, O is oxygen. I'm assuming you already know that from other science classes. But I can write out some sort of symbol for it, okay? You can't write out compound formulas like this for mixtures, meaning you can't write out a mixture using elements from the periodic table. You just cannot. You could describe what's in it, like in soil, you might find certain elements, but sure, but you can't write it out like this, okay? So I'm already thinking it's got to be something that is pure, okay? And it's more than one element together, which makes it a compound. So I'm going to label it as a C. The next one says Br2. So again, I'm noticing that there's this formula where symbols from the periodic table are coming from. Br is an element of the periodic table, but there's two of them. So as soon as you have more than one element together, it's a compound. If it was just Br with no two, that's an element from the periodic table. The next one is salt. Again, there's so many different types of salt. One example of salt is sodium chloride. That's the table salt, literally. That's in a shaker of salt that you put on the table to add to your food. So NaCl is sodium and chlorine together. So I'm telling you that they're two elements combining, which again makes a compound. Water is right here as an example, okay? Hydrogen and oxygen together, so it's a compound because there's two or more elements. Oxygen's an element of the periodic table. I even had that one here. So E for element. Then I'm seeing this, Ca3PO4 in parentheses with a 2. You're noticing that, again, you're writing out these formulas. Ca is from the periodic table, that's calcium. P is phosphorus. O is oxygen from the periodic table. So there are elements here, okay? So it's got to be a pure substance, and there's more than one element together that makes it a compound, okay? So far, the only one that's not a compound is E for element for oxygen. Again, H2SO3. I'm seeing H, hydrogen, sulfur, oxygen coming together, okay, to form a formula here. Compound. The next one there is O3. That means oxygens, but there's 3 of them. That's more than 2. That makes it a compound. Sand. Notice I can't write it out with element symbols, okay? So I'm thinking that's definitely a mixture. And if you think about like picking up a hand of sand, okay, you can even see different parts to it that you could separate using some sort of sifter, okay? So that's a mixture. N is nitrogen from the periodic table. That's an element. Copper is on the periodic table. That's an element. Iron 2 oxide. What that means is it's iron and oxygen from the periodic table. So that's 2 elements coming together. Compound. Okay. So what I need you to do is try these practice problems. So you're going to talk about these 2 questions here and then try to identify what makes them element, compound, or mixture. And then you'll be checking to make sure you understand in your math.